Hello students, let's discuss the worksheet on electrons and electronics. I hope you all solved this worksheet. Just cross-check your answers. For the first question, they're asking, calculate the resistance of a thermistor at this temperature. So here this is a 3 volts. So here the voltage reading is 1.2 volts. It means here it's a 1.2 volts. So across the thermistor, the voltage is 1.2 and the flowing current is from here, that is 0.6 milliampere. So resistance is equals to voltage divided by current. So voltage is 1.2 divided by 0.6 milliamps. If you divide, this will give you 2 kilo ohm or 2000 ohm. Don't forget to convert this milli into 1 milli is equals to 10 to the power negative 3. Calculate the resistance R. So if we have 1.2 volts here, then here the voltage would be 3 minus 1.2, which is 1.8 volts. So resistance R is equal to V by I. Voltage across resistance is 1.8. Current is same, 0.6 milli. If you divide, this gives you 3 kilo ohm. Discuss how ammeter reading and voltmeter reading would change if temperature of the thermistor were reduced. Okay, so here if temperature is reduced and thermistors are made up of a semiconductor elements, then resistance would be a more. So if resistance is more, then total resistance increases. And in this case, ammeter reading decreases. But here for voltmeter, the voltage is equals to current multiplied by resistance. If resistance is increasing here, it means this voltmeter will read more. So voltmeter reading increases. Okay, coming to the next question second. In which circuit will a lamp glow more brightly when less light shines? Okay, so here we can see if here less light is there, but it doesn't matter for the lamp because lamp is connected parallel to the resistor. So here this won't affect. Here in this case, in case B, if less shine is there, it means in that case resistance would be high. And if resistance is high, it means the voltage would be a more. It means more voltage drop here across this LDR. And it is connected parallel to the lamp, so lamp will get that voltage and that will glow brightly. So option B makes sense. And all these cases here, this is wrong because these two are not a LDR. These are thermistors, symbol of thermistors. Question 3. In this part A, on figure 7.1, mark a magnetic poles at each end of both pieces of soft magnet. So this is north, student, so here south will get induced. This is south, so north will get induced. In B, figure 7.2 shows a reed switch. The reed switch is placed between the poles of a strong permanent magnet. State and explain what happened. So here these two are the unlike poles. So you have to say unlike poles attracts and switch will close. Coming to the next, part C. Figure shows two separate electrical circuits, okay? One consists of the reed switch, a cell and a warning lamp. The other circuit has a thermistor, another cell and a coil would round a reed switch. Okay, so first of all, why we are using this warning lamp and why here is thermistor? There's some places where you're not allowed to do a smoking. Anyways, smoking is a bad thing. You won't do smoke. Smoking is not good for health. But if somewhere, if like either in aeroplanes or in cinema halls, if someone is doing smoking, so in that place temperature increases because of the thermistor is there. So as a temperature, uh, on those places, if someone is smoking, temperature increases. As temperature increases, the thermistor resistance decreases. It means then more current will start flowing here, and then this reed switch will close and this warning lamp will lit. So state what happens to the thermistor when temperature of air rises. So you can say as temperature increases, as temperature increases, resistance decreases. In II, explain why the warning lamp lights up when air temperature rises. So you have to explain whole process that as temperature increases, resistance decreases, and the magnetic field in coil increases here in this coil, and reed switch is closed. And now if the reed switch is closed, so current will start flowing in primary circuit. So by this, warning lamp will start glowing. Coming to the next, question 4. In this, the figure 11.1 shows a 9-volt battery connected in series with 16 ohm resistor and a small metal conductor X. Okay, they want us to calculate the current supplied by the battery. Fine, voltage is given, resistance is given. How much resistance this has? In the question they are stating 4 ohm. Okay, so here we can do current is equal to voltage divided by resistance. So voltage is 9, which is given here. A total resistance is 16 plus 4. So 16 plus 4. If you divide 9 divided by 20, this would be 0.45 ampere. Calculate the potential difference across 16 ohm. So we have to calculate the voltage across this. So voltage is equals to current multiplied by resistance. So current is 0.45 multiplied by 16. So 4. So 4 multiplied by 0.45 is 1.8. 1.8 multiplied by 4, 18 4s are 72. So 7.2 volts. Part B. X is connected slowly to a very high temperature. Sketch a graph to show how the resistance of a metal conductor depends on its temperature. So students, if you increase the temperature, resistance of the metal would be keep on increasing. So resistance, temperature, so it would be keep on increasing like this. Next one, state and explain how the voltmeter reading changes as temperature of X rises. So they're asking how the voltmeter reading will change if the temperature increases. Okay, let's go and see. Voltmeter reading will change. Okay, so if the temperature increases, in that case we have a more resistance. It means if the resistance is more, it means this overall current will decrease. It means less current is going here and this is not changing. It means this reading will decrease. Once again, here temperature increases, that's why the resistance increases. Resistance increases, so overall current decreases. So less current is going across the 16, so this voltmeter will read less. Okay, let's frame this in proper sentence. State and explain how the voltmeter reading. So you have to say, as temperature increases, resistance decreases. Therefore, so as temperature increases, resistance increases in metal. This is not a thermistor, students, huh? That's why we have to say resistance increases. In thermistor, it's opposite. If you increase the temperature, resistance will decrease. So resistance increases. Therefore, overall current decreases. So voltmeter will read less. Next, suggest a suitable range for the voltmeter. So here minimum it would be 1 ohm, and maximum let's consider 100 ohm if temperature is very high. So on the basis of that we can figure out the range. So if it's 1 ohm, then the total resistance for 1 ohm, the total resistance would be 17 ohm, and then the current would be 9 divided by 70. 1 minute, let me take my calculator. So 9 divided by 17, this is 0.53. So voltage is 0.53 multiplied by 16. So which is 8.5 volts. So when the resistance is 1 ohm, it's 8.5 volts. Okay, let's check for 100 ohm. So the total resistance would be 116 ohm, because 100 plus 16, current would be 9 divided by 116. So 9 divided by 116, which is 0.077. So voltage is 0.077 multiplied by 16. So multiplied by 16, which is 1.24. So see students, when the resistance is very high, the voltmeter is reading less. So it will, if I consider this infinite, then this will read 0. This, if I take lower, then lower I can take 1.5 ohm, right? So this value would be a little bit more. So here we can say the range of voltmeter, in my case, which I calculated, I can say 1 to 9 volts. But any answer means as per the marking scheme, any answer between 0 to 20 volt of the range is acceptable. Okay, coming to the next. So the range, in my case, I calculate the range 1 to 9 volt. In the next part C, draw the truth table of the NAND gate. So NAND gate, it looks like this. So A, B, and this gives you output A multiplied by B bar. So let's write the input here. So input is A and B. First of all, we have to say C A into B, and then finally A into B bar. So input combinations are like this: 0 0 1 1, 0 1 0 1. So 0 multiplied by 0 is 0, 0 multiplied by 1 is 0, 1 multiplied by 0 is 0, 1 into 1 is 1. If you do the NOT gate, this would be 1, this would be 1, this would be 1, and this would be 0. So this is the truth table of a NAND gate. Next, in fifth, an LDR has a resistance, and okay, so it's 100 mega ohm, and the resistance is 200 ohms. So this is 200 ohms. What is the potential difference between A and B when LDR is dark? So when LDR is dark, in that case resistance would be very high, so voltage would be very high. So which one is the more voltage, student? Just see here. So we can go with the option A, just below 6 volt, and you can take any high value of R and then you can check, you will get the answer close to the 6. When the bright light shines in LDR, so for bright the resistance would be less because more current flows, so voltage would be the less. So take any small value of R like 0.1 ohm like that, and if you calculate you will get the value just above the 0 volt, any small value. Yeah, so for A is right, for B, C is right. Coming to the next, in 6th problem, figure 10.1 shows there is a digital electronic circuit, light sensor, heat sensor, both are there. State the name of the logic gates. So this logic gate is the NOT and this B1 is the AND. In the next B, the light sensor is 1 when the output is bright, it's 0 when it's dark. Okay, light sensor is high output when it's hot, low output when it's cold. So it is bright and cold. Okay, so bright means 1, so here we have 1, and cold means 0, so here we have a 0. State the output of A and B. Okay, so here from A we'll get the 0, so 0, and for B, from here the 0 will go here and 0 multiplied by 0 would be 0, so 0. If it's dark and hot, okay, this is for the I. Now if it's a dark and hot, so let me erase this. Now it's a second case. The second case, dark means 0, so dark means 0, and hot means is also 0, so this will give you 1. So here I have to write for II, output of A is 1, 0 will go here, and 1 multiplied by 0 would be 0, so output of B would be 0. In the next part, they're asking, suggest why B is connected to a relay in order to light the lamp. Okay, so one gate is connected with the relay and lamp, so we can say this for 1 mark, so we can say to provide a current to a lamp. Suggest a practical use of the circuit. What is the practical use of the circuit? There's a relay and lamp and light sensor and heat sensor. So where we're using a light and heat sensor, students, we can say security lamps, we can say in alarm, or you can say fridge alarm. So in these places practically we're using these kind of circuits. Right, so that's it from here. If you have any doubt, you can write me email. I will clarify your doubts. Right, thank you for today.